Hello, happy people of the stats world. This is Mr. Wilcox coming to you from my kitchen table. This week we're talking about sampling and sampling distributions. So we've already talked about the binomial distribution and the normal distribution. So now we're going to be talking about sampling distributions of the mean. So we talked about how to find samples last time. So today we're going to be talking about, like I said, the distribution of the mean. So I'm going to pause for a second so you can pause the video and write this down and just hit play when you are ready. So a sampling distribution of the mean is just like any other distribution we've done. The distributions, remember, are just tables or graphs that show the pattern of what's happening. So this is a pattern of the means from a population. N represents the number of observations in a sample. So number of times something happened. Remember, capital N represents our population size. X bar represents our sample mean. Remember, X bar means mean, whereas mu is our sample, not our sample mean, but our distribution mean. So X bar and mu are slightly different. So one big thing that comes along with distribution of means is the central limit theorem. This is a biggie, so go ahead and write this down in your notebook. I'm going to pause, and when you're ready, hit play again. So what the central limit theorem basically says is that with more and more observations and our population size getting bigger, the means actually, the distribution of the means gets more and more normal. And they tend to have the mean in the middle, just like the normal distribution we learned about earlier. Same thing. So as our sample size gets larger, the means become more normal. It doesn't matter what kind of data it comes from, whether it's skewed or unskewed, the bigger the sample size, the more normal it gets. And so if it doesn't start out normal, you need at least a sample size of 30 or more to start getting this pattern. So we are going to go through an example so that this makes sense. But basically, what it says is we can assume that our sample mean is going to be distributed normally, so we can treat it like a normal curve. Here are the variables we are going to use with our sample distributions. So go ahead and write those down and hit play on the video when you're ready. So like I said before, X bar is our mean of our sample mean. Mu is going to be the mean of our distribution. So our expected value, which is what we learned to do before with mu, so that's not new. What is new for standard deviation is the standard deviation of the distribution divided by the square root of our sample size is going to be what's called the standard error. What this is going to lead into is confidence intervals. And so how confident are we? And is there any error in our data? And that's where that's where this idea is going to start from, is finding the standard error of our mean distribution. So we're going to do an example of that. Go ahead and write down the example. I'm going to pause here so you can do that and hit play when you are ready. All right, so our example is about systolic blood pressure of 30-year-old males. It says it's normally distributed with an average of 122 millimeters per hemoglobin and a standard deviation of 10 millimeters per hemoglobin. A random sample of 16 men from this age group is selected and has a mean of 125. So here's what all those numbers mean. So 122 would represent our mu. 10 is going to represent our standard deviation. 16 is our sample size. And a mean of 125 would be our X bar. So what we're trying to find is our standard error mean. So what we need to find that is our standard deviation and the square root of our sample size. So in this case, our standard deviation is 10. and our sample size is 16. And so the square root of 16 is 4, and 10 divided by 4 is 2.5. Obviously, it's not going to work out to a nice number quite as often. Feel free to go to 2 decimal points if you need to. But in this case, our standard error is going to be 2.5. So, all right, the other thing we can look at with sample distribution means is the probability. And so I'm going to pause here so you can write this in your notebook. And when you are ready, just hit play again. So because the central limit theorem states that our distribution of the mean is normal, we can use z-scores, which we used last chapter with our normal distributions to find probabilities. We can use them again to find probabilities, only our z-score for our mean distribution is slightly different. Remember, our data points are now means, so it's just going to be our mean minus our distribution mean. But instead of using our distribution standard deviation, we're going to use the standard error. So instead of using, again, the standard deviation, we're going to use the standard error when we're talking about sampling distributions. All right. So go ahead and write this example down. As I'm going to pause here so you can write it down, and then just hit play when you are ready. All right. So it says for our blood pressure example with a mean of 122 and a standard deviation of 10, we're going to find the probability that a random sample will be greater than 125. So remember, this is our x bar, this is our mu, this is our standard deviation. So first thing we need to do is find our z-score. So we're going to take our mean 125 minus our mu 122, and this time instead of putting over the standard deviation, we found the standard error, so our standard error here is 2.5. All right, and so if you do your math there, your z-score is 120. So if we want to find the probability that our mean is greater than or equal to 125, we're going to take 1 minus the probability of it being less than a z-score of 1.20. So if you go to your z table, go to the positive side, go to 1.2 and over to 1.20, we get a probability of 0.8849. So in the end, our probability is going to be 0.1151. Right, so it works just like z-scores before. The only difference is our x is now an x bar, our mu is now a mu x bar, and our standard deviation is now a standard error. So I hope this helps. I hope you are all happy. I hope you're all healthy, and I hope you all have a great day.